So Colton, have you ever heard about static electricity?
Yes.
What is it?
It's where you rub two things together, a balloon and a soft thing, and it can pick up something, I guess.
Oh, have you ever been affected by static electricity?
Yeah, someone has shocked me before
Oh, how do you think that happened?
because they rubbed their finger on something soft and shocked.
Oh, so is that like electricity that runs through them, or what do you think it is?
I think it is.
What do you think causes it?
A static electricity move. It gets charged up enough, like you rubbing your hands together, that makes your hands warmer.
Ooh.
And then when you rub them faster, it makes them even warmer.
Okay, so have you ever done a KWL chart?
No,
Okay.
I've never.
So today we are going to do a KWL chart, and we're going to start out with know. What do you know about static electricity? What I want to learn about static electricity, and what I learned. So today we're going to explore static electricity. And by the end of this lesson, you can explain the cause and effect of static electricity and how it interacts between two objects. So let's start off with, what do you know about static electricity?
It can shock.
Okay, it can shock you. What else do you know?
It can pick up objects.
Okay, so when you say pick up objects, what do you mean?
It can pick, I think it can pick up it might be able to stick to glass.
Ooh, you think it can stick to glass? Okay, what else? So what can stick to glass?
The balloon.
The balloon, okay.
Was
And-
it charged?
With it charged. Okay. What else do you think it sticks to?
I think it can pull up paper.
Pull up paper? Do you think it can move things?
I think it can.
Move things. Okay. What do you want to learn about static electricity?
How it can move things.
How it can move things? Okay. Anything else?
And when it can, too.
Oh, when it
And
can.
how fast it can.
Okay.
Because static electricity could change the world if you knew how fast and how slow.
Do you think it is used for anything?
I think it is used for electronics.
Electronics. Okay. Anything else?
I think it can move a certain type of metal, maybe.
Ooh, move metal. Okay. Well, we're going to find out all these kind of things today. But first, I want us to remember our scientific process. Do you remember our scientific process? Have we gone over it before?
Maybe once.
Okay, so can you read these to me?
Step 1, ask a question. Step 2, form a hypothesis. Step 3,
It's okay, sound it out. Plan.
plan a procedure.
Good job.
Step 4, conduct an experiment. Step 5,
Record.
data. Step 6, state a conclusion.
So as we go through this, in a normal classroom, we would have different stations. And at each station, I would have what station number we are, and I would make a question. Can a pen make something rise? If so, how high and rise? How high and wide? So at each station, we would normally find that. In my home, we're going to do it a little different today. But we're going to keep our results on a graphic organizer, okay? So on each top of each graphic organizer, it says station 1, and it has all the different scientific process. Question, hypothesis, procedure, how we're conducting the experiment, recording data, and we're stating our conclusion. And at each station, the students would have 15 or 20 minutes. In this case, we are making it much shorter. So let's go over some vocabulary words, Colton. First of all, attract is to draw near, right? Repel. What is repel? Do you know what that is?
It means push away.
Good job.
Like two magnets on the same side.
Ooh, good. Discharge. When buildup of electrical charge empties into something.
Oh, so like if something shocks me, it's gone.
It discharged.
Yeah, like if a hot wire touched me, it discharges in my body.
Good. Conductor. A material through which electricity flows easily. So can you think of anything like when you're talking about electric fence?
Oh, electricity goes through a wire, and when you touch it, it shocks you.
Yes. What about an insulator? Is a material through which electricity does not flow.
It cannot go through the insulator because it's some kind of organism that pushes it away from it.
Oh, it keeps it, right? It doesn't allow it to come, okay? Lightning.
Lightning forms from clouds that have dropped moisture.
And static
Electricity.
So, circuit, a complete path that electricity can move through. A switch is a device that can open or close a circuit. Can you think of a switch?
Yeah, like our light switch.
Oh, good idea. Let's stay seated. We don't need to shut it off. Perfect. Okay. Electricity is the energy caused by the flow of particles with negative electrical charges. Static electricity is a buildup of electrical charge. An atom, so I wanted to show you a picture of an atom, is the smallest unit of an element that still has the properties of an element. So in here, you're going to see proton, neutron, and electron. So a proton is the part of the atom that has a positive charge. What has a positive charge?
A proton.
Okay, so P equals positive, right?
Mm-hmm.
A neutron has a neutral charge.
So,
Okay, an electron has a negative.
charge.
Electron equals negative, okay? We're going to remember that. What does an electron charge have?
Equals negative.
And what's a neutron? Do you remember that?
A neutron?
I remember it as neutral. Neutral.
So like going backwards.
Yeah, N equals neutral.
So it could go
So
backwards
it's
from that or that.
It could be positive or it could be negative or it could be neutral, which means it doesn't have a charge. Okay, it has no positive and it has no negative. Okay, so we're going to remember these and we're going to refer to these if we need them, okay? So neutron is neutral, electron is negative, and a proton is positive. So if I take this balloon right here, do you think I can move an object with it?
Let's try.
Okay, what am I going to move? Put it on the
A
floor.
Nerf dart.
Oh, no. Can I pick up anything with this balloon? Well, I guess I can pick up a little something there. Let's try a different balloon.
Try and charge it this time.
See, nothing to pick it up. So what are you doing?
You charge it.
Are you charging the balloon? Let's look at your
With
hair.
something soft.
What causes that, do you think? Electrons?
Electrons.
Do you think electrons are causing that?
Yeah. Let's try the Nerf bullet.
Can you move? Oh! Look at that. So what do you think is happening there?
I think the electrons are moving it.
Why would the electrons be moving it though?
Because it's a circular charge going through it, but if I put my finger through it,
What happens?
it falls down.
Okay, so let's charge. I got a sweater unless you want to charge it on your hair. It's fine with me if you want to charge it on your hair. Do you think it will move this?
Let's
atoms, right?
We have atoms in our cells. So if atoms weren't here, we wouldn't be here either.
Correct. So, but the balloon has an atoms on it, right? And let's look at this again. So we have atoms, and inside that atoms are protons, neutrons, and electrons. So when you charge that balloon, go ahead and charge that balloon again.
What happens when you charge the balloon or discharge the balloon? Let's try the can now.
So what do you mean discharge?
So when all the electricity goes out of the balloon into you or whatever you're using, it's moving the can and the...
Okay, let's move the snake away. Let's go ahead and charge it again.
Okay.
So do you think the balloon, you said the balloon's becoming charged. Is it becoming a positive or a negative charge?
A negative.
Why do you say it's negative?
Because a positive charge does something different than a negative charge.
Okay, so
A positive charge is when it's all gone.
what do you think the can has?
A positive charge.
And then what happens when you charge it?
When you charge the balloon, it gives the can a negative charge when you do that.
Does it give it a negative charge or does it attract it?
It attracts it.
Is it attracting? So does positive and negative attract together?
Yeah.
Ooh, so do you think it happens with everything? Do you think we could pick up this?
Let's see. I'm going to charge it again and we'll see. Ooh.
Ooh. So why is it not picking up? So it's trying
It's
to pick
too heavy.
Oh,
Some objects are too heavy for a balloon to pick up.
so could we maybe possibly explore how much something has to weigh to be able to pick it up?
Yeah.
So how would we want to do that? Do you think it will pick this up? Is this lighter than this? Does it have any charge?
No.
I wonder if that's an insulator.
I think it is because it's a type of plastic. An insulator is plastic. And it can be rubber too.
Ooh, so we might have to explore that a little more. Okay,
Let's try the nail.
Okay.
And see what the nail does.
Is it moving yet?
Yeah, it is.
Let's do it one more time so I can see it. One more time because I don't know. I'm shocked at that because it rolled a lot. Did you expect it to do that?
No, because it's heavy.
Oh, I picked up the paper. Let's sign this sign. Move it around. Ooh, try it one more time. So, is a balloon the only thing that can receive a charge?
No.
What else could? Could this, you think?
I think that could receive a charge too.
Okay, let's try it. Let's try it with the snake.
Okay, let's try the snake. It moved it.
Did it? Try one more time. I see, but that was you touching it.
That time.
Maybe try this sweater. This sweater has a real good charge on it because I get shocked all the time. Why would I get shocked?
Because of a negative charge.
Oh. Not picking it up this time, but that's...
Yeah, it did. It just did.
Did it pick it up? Okay. Let's go back to our balloon. What else do you want to try? Do you want to try and pick up anything else?
I want to try and pick up. I want to see if it can stick to the window.
Okay, go ahead.
It's stuck
It's stuck, but it fell down. Why would it fall down, I wonder?
because the balloon is too heavy and gravity too.
Do you think it would stick to the wall? Go and stick it to that wall and see if it'll stick to a wall. Will it stick to a wall or just a glass?
Maybe it only sticks to smooth surfaces. That could be a possibility.
Awesome. So in this case, we would go ahead and pause after they had the opportunity to go through all the different stations and play around and see what it sticks to and what it doesn't stick to. We would watch a video, a follow-up YouTube video that I have in the lesson plan, where the kids would also learn that there are different ways that we use static electricity. So Colton, now that you have watched the video and we have completed all the different centers, we are going to follow back up on the L, what I learned.
Okay.
So can you tell me, first of all, how does static electricity happen?
When you rub two things together.
So we rub two things together. What do we create?
Static electricity.
Okay, and how do we create that?
With a soft thing and a smooth thing or whatever you have around in your house.
Okay. Do you remember any of the scientific terms? What do we start off? What do we have?
An atom.
Okay, so we have an atom. And inside that atom, what is inside that atom?
A neutron.
Okay. How do we create a neutron? A neutron is a neutral charge, right?
Mm-hmm.
So then how do you create a negative charge?
A neutron, and you could also go back with a neutron. You could go forwards. You could do a positive. You could do a negative. You could just
Do you
do a
remember what a negative neutron is called?
A negative?
What is like static electricity? Is there an E word? Do you remember that E word?
Electric.
An electron, right?
An electron.
And what kind of charge does an electron have?
A neutral. An electric charge.
An electric charge or a negative charge, right?
Mm-hmm.
And then what did our can have in this situation?
It had
What charge?
a positive charge.
Good. Which is, do you remember what that's called? Remember, it starts with a P.
Positive?
Positive starts with a P. So do you remember what electron has a positive charge? Is it a
Proton.
Good job. So in this case, we are charging our balloon.
And you know.
And what charge are you getting on that balloon?
Your hair is soft, so you just rub it on your hair. Like
What kind of charge does that balloon have, though?
It has an
Yes, you had it. You had it.
Electric.
I had a negative charge.
Negative.
And what does the can have?
A plus charge.
A positive.
Positive charge.
And what are you doing? What does the can do?
It makes it move.
And it makes it move. But what does it do? Does it attract it? Does it repel it?
It tracks.
Oh. So now, did we learn how it works? Can you tell me also what static electricity is good for?
It could change the world.
How does it change the world? What do we use it in?
We use it in electronics.
What kind of electronics?
Like, it is used for Xerox machines.
Mm-hmm.
It's used for 3D printers. It's used for cars. And it's used for thunderstorms.
Oh, so thunderstorms are part of it?
Yes.
Oh, so the thunderstorms are part of it. Okay. Can you explain a little more on that?
A thunderstorm, when it comes down on the bottom of the cloud, it's rain and it's thunder.
And it creates a negative charge. And what's the earth have?
A positive charge.
Good job. Okay.
Like a compass. So a compass is used for
a compass is magnetic. Yeah.
And it can be, since the earth is positive charge, north, east, south, west.
Ooh, So maybe we'll take a look at magnetic charges next week. Thank you so much, Colton. I appreciate you helping me out with this. You have a good one.